This is SpaceTime, Series 25, Episode 2. Coming up on SpaceTime, new evidence confirms the children of the inner solar system. Black holes discovered gouging out gigantic bubbles in a massive galaxy cluster. And France launches its new Signet spy satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that the Earth and Mars were formed from material that largely originated in the inner solar system, with only a tiny percentage originating beyond Jupiter. The findings, reported in the journal Science Advances, provides the most comprehensive comparison so far of the isotopic composition of the Earth and Mars and pristine building material from the inner and outer solar system. The new findings have far-reaching consequences for science's understanding of the processes which form the inner planets of the solar system, the terrestrial worlds Mercury, Venus, Earth and Mars. It means a hypothesis that the four rocky planets grew to their present size by accumulating millimetre-sized dust pebbles from the outer solar system isn't tenable. Approximately 4.6 billion years ago, a collapsing cloud of molecular gas and dust condensed out into a protoplanetary disk orbiting around the young nascent Sun. Now, two theories describe how, over millions of years, the inner rocky planets formed from this original building material. According to the most widely accepted theory, dust and gas in the inner solar system accreted into ever larger chunks, first through static electricity and then later through gravity, gradually growing bigger and bigger and forming planetesimals as big as the Earth's moon. Collisions between these planetary embryos eventually produced the inner planets that we see today: Mercury, Venus, Earth and Mars. However, another hypothesis recently emerged which postulates that millimetre-sized dust pebbles migrated from the outer solar system towards the Sun. Along their way, they accreted onto planetary embryos of the inner solar system and step by step enlarged them to their present size. Both theories are based on theoretical models and computer simulations aimed at reconstructing the conditions and dynamics of the early solar system. Both describe a possible path for planetary formation. But which one's right? Which process actually took place? The study's lead author, Christoph Burkhardt from the University of Munster in Germany, says to find the answer, scientists first need to determine the exact composition of the rocky planets Earth and Mars. To achieve this, they examined isotopes of the rare metals titanium, zirconium, and molybdenum. These are found in minute traces in the outer silicon-rich layers of both planets. Isotopes are different versions of the same element which differ only in the weight of their atomic nucleus. Their nucleus has the same number of protons, but different numbers of neutrons. The authors assume that in the early solar system, these and other metal isotopes were not evenly distributed. Rather, the abundance depended on the distance from the Sun. That's because different elements will condense out at different temperatures and distances from the Sun. They therefore hold valuable information about exactly where in the early solar system a certain body's building blocks originated. As a reference for the original isotopic inventory of the outer and inner solar system, the authors used two types of meteorites. These chunks of rock usually find their way to Earth from the main asteroid belt between the orbits of Mars and Jupiter. They're considered to be largely pristine material from the beginnings of our solar system. One type of asteroid is known as a carbonaceous chondrite. That's because it contains a few percent of carbon, and they're known to have originated beyond Jupiter's orbit and were only later relocated to the asteroid belt due to the influence of the growing gas giants. Their carbon-depleted counterparts, the so-called non-carbonaceous chondrites, were formed in the inner solar system. The precise isotopic composition of Earth's accessible outer rocky layers and that of both types of meteorites have been studied for some time and are now well understood. However, there has been no such similar comprehensive analysis of Martian rocks. So, the authors examined samples of 17 meteorites known to have originated on the Red Planet. These would have been blasted off the surface of the Red Planet by asteroid impacts, floating in space for a while until eventually being caught up in the Earth's gravity. The 17 meteorites were assigned into 6 typical types of Martian rock. The authors also investigated the abundances of the 3 different metal isotopes. The samples of the Martian meteorites were first powdered and then subjected to complex chemical pretreatment. The authors used a multi-collector plasma mass spectrometer at the University of Munster to detect tiny amounts of titanium, zirconium and molybdenum isotopes. They then performed computer simulations in order to calculate the ratio in which building materials found today in carbonaceous and uncarbonaceous chondrites must have been incorporated into Earth and Mars in order to reproduce their measured compositions. In doing so, the authors considered 2 different phases of accretion to account for the different history of the titanium and zirconium isotopes as well as the molybdenum isotopes respectively. Unlike titanium and zirconium, molybdenum accumulates mainly in the metallic planetary core. The tiny amounts still found today in the silica-rich outer layers can therefore only have been added during the very last phase of planetary growth. The researchers' results showed that the outer rocky layers of both the Earth and Mars have little in common with the carbonaceous chondrites of the outer solar system. In fact, they account for only about 4% of both planets' original building blocks. If early Earth and Mars had mainly accreted from dust grains from the outer solar system, this value should be almost 10 times higher. But the authors also found that the composition of the Earth and Mars doesn't exactly match the material from the non-carbonaceous chondrites of the inner solar system either. The computer simulations suggest that another, different kind of building material must also have been in play. Burkhardt says the isotopic composition of this third type of building material, as inferred by the computer simulations, implies that it must have originated in the innermost region of the solar system. Now, because bodies in close proximity to the Sun are almost never scattered into the asteroid belt, the material is almost completely absorbed into the inner planets, and thus does not occur in meteorites. Mind you, the surprising finding does not change the overall results. The inner planets are indeed children of the inner solar system. This is SpaceTime. Still to come, black holes carve out gigantic bubbles in a massive galaxy cluster, and France launches its new Signet spy satellites. All that and more still to come on SpaceTime. Astronomers have discovered 4 enormous cavities or bubbles at the centre of a galactic cluster. They appear to have been carved out by a pair of erupting supermassive black holes closely orbiting around each other. The discovery, reported on the pre-press physics website archive.org, was made by NASA's Earth-orbiting Chandra X-ray Observatory. Galaxy clusters are the largest structures in the universe held together by gravity. They're made up of hundreds to often thousands of galaxies, vast clouds of ionized gas, and mysterious dark matter. Now, the ionized gas which pervades the clusters contains much more mass than the galaxies themselves, and it glows brightly in X-rays. And an enormous galaxy is usually found at the centre of each cluster. A new Chandra study of the galaxy cluster known as RBS 797, located some 3.9 billion light-years away, uncovered 2 separate pairs of cavities extending away from the centre of the cluster. Now, these types of cavities or bubbles have been seen before in other galaxy clusters. Scientists think they're the result of eruptions from regions near a supermassive black hole in the middle of the massive central galaxy. As matter is ripped apart and falls into a feeding black hole, some of it's diverted by powerful magnetic field lines into 2 beams or jets, which shoot out perpendicular to the black hole's accretion disk. These jets blow cavities into the surrounding hot gas. The revelation in RBS 797 is that there are 2 pairs to these jets directed perpendicular to each other. Now, the most likely explanation for 2 pairs of cavities from 2 sets of jets is that there must be 2 separate supermassive black holes, probably in the process of eventually merging. Astronomers originally observed a pair of cavities in the east-west direction, but the pair in the north-south direction was only detected in a new, much longer Chandra observation. This new deeper image uses almost 5 days of Chandra observing time, compared to the 14 hours of the original detection. The National Science Foundation's Very Large Array in New Mexico has already observed evidence for 2 pairs of jets as radio emissions which line up with the cavities. One of the study's authors, Miriam Gitti from the University of Bologna in Italy, says the current hypothesis involves supermassive black holes forming a binary system. But she says it's extremely rare that both of them are observed in an active phase. In this sense, the discovery of two close active black holes inflating cavities in RBS 797 is quite extraordinary. A radio observation with the European Very Large Baseline Interferometer Network discovered two radio sources separated by only about 250 light years in RBS 797. Now, if both sources are supermassive black holes as suspected, they're among the closest pair ever detected. The two black holes should continue spiraling towards each other, generating huge amounts of gravitational waves and eventually merging. However, another possible explanation for the four cavities seen in RBS 797 involves only one supermassive black hole, with jets that somehow manage to flip around in direction quite quickly. Analysis of the Chandra data shows that the age difference for the east-west and north-south cavities is less than 10 million years. Now, if there's only one black hole responsible for all four cavities, then astronomers will need to trace the history of this activity. The key questions will be how the jet's orientation changed so quickly, and whether this is all related to the galaxy cluster's environment or to the physics of the black hole itself. This is SpaceTime. Still to come, France launches its new Signet spy satellites, and a Turkish delight reaches orbit. All that and more still to come on SpaceTime. Arianespace has successfully launched a Vega rocket carrying 3 new French spy satellites into orbit. The Signals Intelligence Gathering spacecraft were launched from the European Space Agency's Kourou spaceport in French Guiana.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, stop. Allumage P80 et décollage. Propulsion est nominale, le guidage est nominal.
I'm always impressed, and it's incredible to see that full daylight, no clouds today. It's absolutely wonderful. The Vega launch has been flying for 45 seconds. So acquisition by the Saint-Jean station, and that's the 12th launch for the year for Arianespace. A perfect launch so far. So we've just heard acquisition by Saint-Jean. What does this mean? It's a telemetry station based in the west of Guyana, and as the launcher is in altitude thanks to the P80 stage, we have acquisition by this station so that we have contact with the launcher for the first phase of the flight. The P80 is the first stage, and in 40 seconds it will be separated from the rest of the launcher. It's active for 2 minutes roughly, and once it's finished its boost and it's empty, we separate it. It takes off very fast because we have 230 tons of thrust that's delivered by the P80, and you have to look at this in relation to the weight of the launcher, which is twice as low. So it's an impressive thrust, and the launcher takes off very fast. The separation of the P80, it's been confirmed, and we see that the Zefiro 23, why several stages, why several engines? Well, the principle is to get rid of dead weight when you don't need it anymore. So when a stage is over and has consumed all its propellants, if we keep it on board, we carry dead weight in space, and that's costly. So that's why we have different stages in a launcher, so that we can get rid of dead weight as we go. The trajectory is nominal, says the DDO. Okay, that's the end of thrust by Z23. That's coming to an end, and we will have the separation of the second stage.
The payloads were released about 56 minutes after launch. Designed and built by Airbus Defence and Space and Thales, the 3 series military satellites, with a combined mass of 1,346 kilograms, are designed to monitor the electronic signals and intelligence networks of other nations. Prior to this launch, only the United States, Russia and China had this level of signet capability. The series satellites are flying in a triangular formation at an altitude of around 700 kilometers. monitoring enemy radars, anti-aircraft defense batteries, and communication centers.
I want to ask you a question about the satellites. Can we talk about spy satellites? Well, intelligence satellites. Until now, we could take pictures of the Earth with our CSO military satellites. With Ceres satellites, now we will be able to capture electromagnetic transmissions. Why is that important? Well, when you want to collect intelligence and find out what type of ship is in the China Sea or the Mediterranean Sea, we listen to the ships you are monitoring, and they are specific to every type of equipment. A Russian ship is not like a Chinese radar or an Iranian one, and when we compare this data, we'll be able to know exactly what ship and nationality we are dealing with. And before that, we didn't know that. We had no satellites to listen to that, not in the electromagnetic field. We only had demonstrators, prototypes. We were training, we were testing these technologies, but we were not using them in our military operations. With Ceres, as of next year, we will be able to use the intelligence from Ceres for our operations in the field. So it's a major change. Before, we had to ask this information from our neighbors beforehand. Yes, we could cooperate with allied countries. Now we'll be completely autonomous and sovereign. France is in the 5 first countries worldwide to have this type of capability.
The launch was the 12th for the Vega rocket system, and it marks the start of a transition period from the existing Vega to the new Vega C, which will undertake its maiden flight this year. This is SpaceTime. Still to come, a Turkish delight reaches orbit, and later in the science report, how smart really are brain surgeons and rocket scientists? All that and more still to come on SpaceTime. SpaceX have launched a new Turkish telecommunications satellite. The Turksat 5B was flown aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida. The first stage booster used on this mission was on its 3rd flight. It returned safely to the planet's surface, landing on the drone ship a short full of gravitas, which had been pre-positioned downrange in the North Atlantic Ocean. The 4,500-kilogram Turksat 5B was built by Airbus Defence and Space on a Euro 3000 EOR platform. It'll provide television and internet broadcast services covering Turkey, the Middle East, Europe and Africa. Its sister satellite, Turksat 5A, was launched by SpaceX a year ago. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that giant fractures in the floating ice sheets of Antarctica's massive Thwaites Glacier could shatter part of the ice shelf within 5 years. The collapse would cause the existing buildup of ice on land to carve more quickly, creating what scientists have described as a doomsday scenario. The findings, reported in the journal Nature, warn that if Thwaites were to collapse completely, it would raise sea levels by around 65 centimetres. The list of the top 10 government-subsidised medicines prescribed in Australia between July 2020 and June 2021 has now been released. According to Australian Prescriber magazine, 8 of the most used medicines were for cholesterol lowering and blood pressure, with the rest being for diabetes and for depression and anxiety. The results aren't all that surprising, as cardiovascular disease is the leading cause of death in Australia. The inclusion of antidepressant medications on the list was new this year and has since moved up to number 8, reflecting the rising number of people who are experiencing depression and anxiety disorders as a result of the COVID-19 pandemic. The Australian Army has ordered 30 K9 Thunder self-propelled 155mm howitzers, as well as 15 K10 armoured ammunition resupply vehicles. The contract's been awarded to a South Korean company which will build the weapons in Geelong. The 48-ton 52 caliber K9 platform has a crew of 4 or 5 depending on configuration. It has an ammunition capacity of up to 48 rounds, with a further 104 rounds supplied through a robotic resupply vehicle which is based on the same chassis. The new systems will replace 36 of the existing M198 towed howitzers. Well, it seems the old sayings, it's not rocket science or it's not brain surgery, might not be the best way to describe stuff requiring a lot of brain power. A new study reported in the British Medical Journal has found that rocket scientists and brain surgeons are no smarter than the general population. Researchers compared the intelligence of 329 aerospace engineers and 72 neuroscientists with 18,257 members of the general public. All participants completed validated tests to measure 6 distinct aspects of cognition, spanning planning and reasoning, working memory, attention, and emotion processing abilities. Potential influential factors such as gender, handedness, and experience in their speciality were all taken into account in the analysis. The research shows that aerospace engineers and neurosurgeons were equally matched across most domains, but differed in 2 aspects. Aerospace engineers showed better mental manipulation abilities, whereas neurosurgeons were better at semantic problem solving. Aerospace engineers didn't show any significant differences compared to the general population. And while neurosurgeons were able to solve problems faster than the general population, they showed slower memory recall speed. The results suggest that despite the stereotypes, rocket scientists and brain surgeons have the same wide range of cognitive abilities as the general public. But knowing that isn't rocket surgery. The Victorian government has tried to suppress legal proceedings showing that QR code safe COVID check-in contact data tracing isn't being destroyed after 28 days as originally promised, but is being retained and archived for future use. The revelations, reported in Melbourne's Herald Sun newspaper, follows a protracted legal battle over the QR code data between the Victorian Health Department and the workplace safety watchdog over access to the archived data. It seems the Victorian government fought to keep the story suppressed in order to prevent the public from learning that contact tracing data isn't being destroyed after 28 days and so isn't as secure and confidential as they promised it would be. It follows on from previous revelations that Australian Federal Police, as well as police in Victoria and Western Australia, and even a credit checking agency, had requested QR code check-in data to track people's movements. While the Western Australian government has now tightened its legislation, the Victorian government still allows access. Technology editor Alex Zaharov-Reut from ITWire.com says it shows that your digital footprint is never totally safe.
You can have organisations, governments even, of any persuasion that promise that QR code information and the tracking of where people are going will be confidential and only be used for the purposes of tracing where a virus has gone. The question is, whenever you're online, your footprint, your activity is being tracked and traced. I mean, you can use a VPN, you can use ad blocking software, you can use various things to try and mask your activity online. But you've got companies out there who are fingerprinting browsers and doing whatever they can to try and even doing things like fingerprinting fonts to try and track where people are going. They can make promises about certain things, and usually the truth comes out that this information wasn't as private as promised, and you don't know who to trust online anymore. We seem to be living in the age where privacy is, gone, and we'll be the ones telling our children what it was once like to live in a world where things were private, to sort of mangle Ronald Reagan's famous saying about, you don't want to be the generation that lets liberty slip through your fingers and tell your children what it was like to once live in a world or a country that was free. So I guess it's disappointing to hear about this, but is it any surprise? Part of the whole internet is tracking. People want to know what ads you've seen, what websites you visited. I was looking at a site just earlier today, and you had to agree to all these cookies, and so I went to the thing that said configure, and there was about 50 different things that I had to disable. It wanted to measure ad performance. It wanted to measure all these different things. And this is one example why Apple has advertised in its macOS 12 that it is, or in its previous versions of macOS that exist up until today, that they're trying to make it much more difficult for companies to track where you're going across the internet. They're trying to make it so that one Mac looks like every other Mac. And there are programs you can buy for your PC and even for your phones that can block as much of this tracking as possible. There's an app on iPhones called OneBlocker, for example, and it has an inbuilt firewall that activates what looks like a VPN. It says it's a VPN, but the traffic isn't actually going anywhere. But what it's doing is blocking all the ads inside of apps. And so one of the apps that I've been playing with is an app called Wombo, W-O-M-B-O. It allows you to put your face and make it sing all these different songs. And when I have the VPN/firewall on, I don't see any ads. But if I turn the VPN and firewall off, every time I've made one of these little Wombo video clips, I have to put up with an ad. And obviously, they want you to pay money to be able to switch the ads off and to get faster processing and high quality processing. But I didn't realize that the app had all of these ads in it because I've had this one blocker with the firewall for some time. And so it was quite a surprise when I disabled that I used it on a different phone that I didn't have the one blocker on. And I noticed all of these ads popping up, and it was really quite annoying. They really wanted you to pay the $8.99 a month. So there are definitely technologies you can use to minimize or to block as much of that tracking as possible. But there's plenty of people out there.
VPN's the way to go with that sort of stuff?
Well, VPNs are certainly one way to route your traffic through a different country or a different service that can't be, in theory, tracked or traced back to you.
Well, we were talking about DuckDuckGo last week.
Well, yes, and that's one browser that's coming in 2022 sometime. We don't exactly know when. But, there's a whole industry now around trying to block the trackers, block the fingerprinting, and restore some of that privacy. So we've got this battle between two sides of tech, one side trying to increase the amount of tracking and the other side trying to minimize it. And I think this is a battle that will continue for a long, long time.
I guess that means if you get something that's free online, it means you're the product.
That's right. You might think you're consuming that social network, but really that social network is consuming you and selling information about you to advertisers and to the highest bidder. I mean, that's how often companies will monetize a free service. They have to collect data and collect information. Today it's all about analytics, gathering information and actually making use of the data and drilling down. It's something that we were never able to do anywhere near as effectively as in the modern age. And decades ago, there was a famous saying by a businessman that said, look, I know that 50% of the advertising I do is completely wasted. I just don't know which half. But in the modern world, the advertisers know with great specificity where that advertising is dollar, if people have clicked on ads, if they've seen things in emails. I mean, we even now have email programs that will strip out all of the trackers because an advertiser can know that you've opened an email, and even if you've clicked on a button, and then theoretically they know if you've purchased something. So you can be tracked very precisely. The analytics are just incredibly accurate, and that's why there's an industry to try and muddle that information, to block it, and to try and restore some of the digital privacy.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.